What you see behind me is the motion capture system here at Appalachian State University. And these cameras are used to capture performance of sport movement or any kind of movement that we're looking to analyze. And then that information is fed into the computer and then can be analyzed to determine exact joint positions, joint angles, and that sort of thing, depending upon the model that's being used with the data that's being collected. The cameras that are in here are by a company called Vicon, and they're kind of the main company that does motion capture types of cameras. And the difference between these cameras and a traditional kind of normal camera you'd use to film anything going on would be that they capture at a much higher frame rate. That's kind of one of the main distinctions. A normal camera will capture at, say, 30 to 60 frames per second. These capture at about 240 frames per second. So there's a lot more data being generated by the cameras. Additionally, the cameras don't detect and give you an image that you normally would kind of suspect to see on a camera, and that the difference is that they're only going to pick up on specific reflective markers, and so they're only going to track certain data points of your performer as they're going through whatever kind of action they're doing. So let's take a look and see how these things work in action. Alright, so I've got you positioned over my shoulder here, and we're working at the computer that's going to analyze any kind of our data. And you can see on the screen here, we've got a three-dimensional area, a grid set up here, and you can see up above there's these green rectangles. Those represent the different cameras. So our Vicon system is a 7-camera system. And the value of having multiple cameras is that you're less likely to lose a data point. And one of the issues you have in any kind of motion capture is that if none of the cameras can see a specific data point, you lose that specific piece of data. Let me show you an example. So in this motion capture, we've got a person doing a drop jump. So they're staying on top of a box, they drop off the box, they land, and then they jump up into the air. And in this video, as I scrub it along here, you can see our person is in this normal model here, and you can kind of see the markers are set up so that we've got this individual's right ankle, right knee, right hip, and then left ankle, left knee, and left hip. And this model has been developed to help us analyze the ground reaction forces and the joint angles that occur while this person lands. And as this action goes on, the data that we've already collected, you can rotate around in all 3 dimensions, on 3 directions, because that's the way the motion is captured. It's a 3D capture system. So as they land and hit the force plate, this red line that goes up, this is the ground reaction force coming up from the force plate that's embedded into the motion capture studio here. In fact, most of the time in a lot of motion capture setups, you have both kinematic data coming from the cameras and also kinetic data or force plate data that are linked together in order to kind of tell you what's going on. So we have this force that's coming up from the ground, this equal and opposite ground reaction force. And then right here you can see we lose this marker on this left ankle. So it's unlabeled, you can see at this point. The other markers, if I hover over them, they're going to tell me what those points actually are. And so we lost this data point. And what could have happened is that if this person was wearing long pants, for example, the pants might have covered that marker. The marker might have shifted a little bit to where essentially the tracking system has lost track of that marker. It's still tracking it here, but it's not able to identify which marker it's supposed to be. So in this case, what I've got to do is I've got to go and I've got to relabel that marker. So from here, we still have it. Essentially, I find the frame where we lose that marker, that data point, and then I can go ahead and I can relabel it. So I know that that's supposed to be the left ankle, so I go ahead and I click on left ankle here, and then identify that spot, and now it's corrected for us. And so now when I go through the data, that data point is now being collected for us. So one of the issues that happens with data collection is that you can lose markers. The marker could actually literally fall off the person because they're just stuck on to their joint segments. They could be covered up. So in our motion capture studio, we try to keep it pretty empty of things, but if they're dropping from a box, for example, or if they have to jump over a barrier, that barrier at a certain point might cover up that marker so that the cameras lose track of it. And again, the idea of the multiple cameras is to minimize the chance of losing a data point. So as long as 1 or 2 cameras can see that data point, you can still track essentially kind of where it is in place. But if none of the cameras can find that data point, you have to go and try to interpolate or figure out where that data point would be based upon its relation to the other markers. And so there's a lot of cleanup that's involved in any kind of data collection that's done with motion capture. There's a fair amount of cleaning of the data you have to do afterwards in order, before you actually go and analyze that kind of data. And so a multi-camera system, like a 7-camera system here, is nice, but if you had even more cameras, you minimize the chance of that occurring. In addition, a lot of times what you'll try to do is try to avoid having a person wear anything that has reflective material on it, and I'll give you an example of that here in a second. So you're looking at a live view of our motion capture area, and what I'm doing is I'm just waving around a wand that has reflective markers on it. This is used for calibration, and you can see the reflective markers are picked up very well, but you can also see there's some extra noise that's going on here. Here I'm standing on the force plate and jumping around on it, it's registering that force that I have. And as I move around the capture suit, you can see there's kind of blinking lights that are kind of going on. That's actually coming from my pants. I've got a little marker here, or just a logo essentially on my pants. And it's reflective enough that every once in a while it picks up that stray data point. And so like I said, the person that you're going to collect data from, you're going to try to make sure that they're dressed in such a way that you avoid those data points. And typically, if you ever see any kind of real motion capture setups, like for movies and things, they're wearing essentially skin-tight clothing in order to reduce the chance of having any of the markers be covered up by their clothing as they move around and act as they need to for that performance. The information from all the cameras is fed into a special unit here, which is designed to take the analog signal that comes from the cameras and convert it to a digital signal and then send it into the computer. So the computer is going to record or take the data from the cameras, but it needs to read them in a digital format. So that box is necessary to convert the analog camera data and then convert it into a digital signal. And then each of those data points is then taken and coordinated into space based upon the calibrated capture area that we have with our system. And then we can know exactly where those points are and then calculate speeds, velocities, accelerations, whatever it is we're looking to accomplish. That data can all be collected using the computers and then analyzed for whatever purpose is necessary for the research study.